Hello class, welcome to lesson 2. This one is going to be a review on polynomial basics and what the book really means by that, and what we're going to be talking about today is basically sort of the arithmetic of polynomials. So like adding and subtracting, multiplying polynomials, stuff like that. The next lesson will be factoring. And then the lesson after that will be actually dividing them. But we're going to start with this, which is going to be basically a review on combining like terms, which I'm sure most of you remember how to do, but we'll look at anyway. And review on distribution techniques like FOIL, which I'm sure most of you also remember. But for those of you who need a bit of a refresher, stick around. Okay, we'll start with what a polynomial is to begin with. The best way to describe it really is that all the powers of x you have are nice. And what do we mean by nice? Well, a polynomial basically has only x's or that have positive whole number powers, right? So nice powers. Like for example here, x squared plus 3x plus 1, all my x's have nice powers. Okay. This second example here, this x to the 100th plus 3x to the 22 plus 13x, that is also a polynomial because all my powers of x are nice, right? They're positive, they're whole numbers. They might be fairly large, like here x to the 100 might be kind of unwieldy to deal with in certain situations, but it is still considered a polynomial. So these two guys are polynomials. Okay. And the highest power of x that you see is actually called the degree. Okay, so the highest power of x for this first guy is 2. So the degree here is 2. And the highest power of x we have here is 100, so the degree is 100. All right. Another thing to note, that both of these polynomials are in what we call standard form. Standard form just means we put everything in order, right? So the highest power of x goes first, the next power of x goes second, and the lowest power of x goes last, and very last is the constant, which it doesn't have an x. Okay? These next few examples here are not polynomials. This is not a polynomial. Even though we have x squared, the next piece is x to the negative 1, so that is a negative exponent. So we have no polynomial there, no degree. This one with the square root, if that might be a little too close together there. Let me kind of change the way that looks a little bit. That's the square root of x plus the cubed root of x. Well, if you remember from the last lecture, these are just fractional exponents, right? That's going to be x to the 1/2 plus x to the 1/3. Those are roots. Well, this is not a polynomial because the power of x are fractions. So they're positive, but they're not whole numbers. All right, and then this one here is actually not a polynomial either. This is technically a polynomial divided by another polynomial. That's a different type of thing that we'll be talking about in a couple of sections. But so this is not a polynomial. And another thing we can do here, we can actually split up fractions, right? I talked about it one way. We can do this in one direction in the previous lecture, but we can do it the other way. If we have a fraction over a single denominator like this, we can actually split this up to be 3x over x plus 1 over x. Okay, and then in this first piece, the x's cancel, and here this is 1 over x, and if you remember from the last video, this changes to be x to the negative 1, since this is technically x to the positive 1 in the denominator. So here we have an x with a negative exponent once again. All right, so these examples here are not polynomials. Okay, we don't have what we call like a degree for that. You could just identify what the highest power of x is in each case, but really the term degree is really just set aside for actual polynomials. You might be wondering what the big deal about polynomials is. Well, there is actually a section we'll be looking at as we move along later on in the semester that details polynomials and why they're important, and we'll be spending a lot of time on them. So don't worry about that too much right now. So what we're going to be looking at instead, and this is part of the review process, we don't actually necessarily expect you to know everything about polynomials just yet, but we do hope that you somewhat remember how to add, subtract, and multiply these guys. And so that's what we'll be looking at next. Okay, we'll start with an example of addition. We're going to take this polynomial here, this 5x squared plus 3x plus 2, and then we're going to sum it up with 4x squared minus 10x plus 8. Okay, so what we do here is we basically just go through and combine our like terms. We're going to take these x squareds, we're going to take these x's, and we're going to take these constants and sum them up or subtract them or whatever together. Okay, so this 5x squared and this 4x squared, I'm going to put them together and say this is 4x squared. I should do it in order. So it's 5x squared plus this 4x squared. Okay. So here are my x squared terms. I'm going to take my x terms. I have a plus 3x, then a minus 10x. Okay. So here are my x terms. And then I'm going to take my constants. I have my plus 2 and my plus 8. Okay, and I'm going to add these up separately. And we combine our like terms how you might expect. So, and hopefully you've seen this before, but if not, we'll start here. If I have 5x squareds and another 4x squareds, the question is, how many do I have in total? Well, 4 plus 5 is going to give me 9, so I have 9x squareds. And that's all you're doing when you're combining like terms. It's just telling me how many x squareds do you have. Right? If I have 5x squareds here, and I'll give you another 4x squareds, you have a total of 9x squareds. Same thing here. If I have 3x minus 10x, that's going to be a minus 7x. I just take 3 minus 10, do that subtraction, negative 7. Okay. And that's how many x's we have. And then 2 plus 8 is going to be 10. Okay. So this problem actually happens to be in standard form, right? It's in order, and the degree of this polynomial is 2. And that's that. All right, next up, let's look at this example here. We have something a little more involved. We have x to the 10th plus 10x to the 4th minus 3x squared plus 10, then all minus 7x to the 9th plus 8x to the 4th plus 2x squared plus 11x minus 20. Okay, so first things first, with subtraction, and this is something that a lot of people forget to do, make sure that you start by distributing this minus sign across everything. Okay? So many people forget this. It's a really, really big mistake. A lot of people will just let this minus sign apply just to that 7x to the ninth, when really, since this whole thing's in parentheses, it's distributing across the entire thing. Okay, so you can basically just start by changing all of these signs. Okay, so I'm going to do that. I'm also going to drop the parentheses, because a lot of times when you're working with these things, let me put a line up here to break that off. Yeah, a lot of times when you're actually doing these things, you're combining all your like terms, you don't usually have the parentheses. But in these problems, the work does sort of give you parentheses to try and break things up for you, help you out a little bit. All right, so what we're going to do, we're going to go ahead and distribute this negative sign. So this will be negative 7x to the ninth minus 8x to the fourth minus 2x squared minus 11x. And then here, this minus 20 is going to become a plus 20. So all we're really doing is just changing all the signs. Then this piece over here, I'm just going to leave alone, except I'll just go ahead and drop the parentheses. Alright, so it'll be 10, or x to the 10th plus 10x to the 4th minus 3x squared plus 10. Okay. So we could actually go through and rewrite it like we did last time, where we just put everything together. Or what we could do is just kind of think about it piece by piece, right? And just combine like terms. One thing to keep in mind is the power of x doesn't complicate things just yet, because all the power of x does is just tells you what type you have. Remember, you're combining like terms. So when I go to sum up my x to the 10ths, I'm going to go and look through and see if I have any other x to the 10ths. I do not. So we're going to have one x to the 10th, and I can go ahead and check that off. Okay. Next up is x to the 4th. Okay. And I'm just going by how I see them in this line. Okay. You could go by what order you want to go in. Personally, I just kind of like to go in the order I see them and then rearrange them if I have to later. But again, it's up to you. But next thing I see is this 10x to the 4th. So I have 10x to the 4th. Then the other x to the 4th I see. So let me use a dot for x to the 4th. The other x to the 4th I see is right here, this minus 8x to the 4th. All right, so 10x to the 4th minus 8x to the 4th. 10 minus 8 is going to be 2. So I have plus 2x to the 4th. So these guys are taken care of. Okay, next thing I see is this minus 3x squared. Okay, so I have a minus 3x squared here. I'll use a little red square for square. 3x squared. And then the other x squared I have is here, a 2x squared. Right? And we have to be careful because this is a minus 3x squared minus a 2x squared. So minus 3 minus a 2 gives us a negative 5x squared. Okay. All right, so those are taken care of. The next thing I see is this constant 10. So I'll look for constants. I have a 10 here and a plus 20 here. So 10 plus 20 gives me plus 30. So I'll mark those off just with my pencil. All right. Now everything over here is pretty much taken care of. And maybe I should use red so it's more consistent. Okay, everything over here is taken care of. So now, and the reason, part of why I like to do it this way, is I know when I go to look for more powers of x, they're always going to be to the right. They're always going to be this way. So I know I can like look here and look that way. Okay, so x to the 9th, I have this negative 7x to the 9th, and I actually don't have any others because the only other thing I have left is this 11x that hasn't been taken care of. Okay. So we're just going to have this negative 7x to the 9th. And that's taken care of. Let's mark that out in the opposite direction. Then all that's left, these are taken care of already, and then all I have left now is this minus 11x. There's nothing else to sum it up or subtract it with. It's all on its own. Okay, and there we go. The operation is now complete, but if you were asked to put this in standard form, you would need to move things around a bit because these aren't really in order. I have an x to the 9th here. That should move here behind the x to the 10th and in front of this x to the 4th. And it moves with its negative sign, right? So it has to move with its sign. Don't forget that. And then this x, I would move in between the x squared and the constant there. Okay, so in my next line, I'll do that. This will be x to the 10th minus 7x to the 9th plus 2x to the 4th minus 5x squared minus 11x plus 30. And there we go. Okay, so this is a standard form. Now be careful, a lot of the problems on the homework will ask you to put it in standard form. All right, so make sure if you're doing it like I did here that you just reorder everything before you put in your final answer. All right? Then if it asks you for the degree here is 10. And there we go. Okay, and that's kind of how we go about it. If we had a bunch more, if we had like 3 or 4 different polynomials moving around, we'd do it in the same way. We just combine all our like terms. And we combine based on the powers of x. Right? We don't take this like x to the 10th and x to the 4th and add the powers together to get like x to the 14th. You might laugh, but I have seen that before, even from my Calculus 3 students. So these are mistakes I am trying to identify to you for a reason. But do keep in mind when adding and subtracting, and that's what we're doing here. So remember the last time we were multiplying. When we were multiplying, we added exponents. But here when we're adding or subtracting x values, we just combine via our like terms. So we just have to match up our powers of x to do that. So I can see why one might get confused. We're going to move to multiplication now, because the second step of our multiplication is always doing addition like this, or subtraction. So instead of doing a bunch of examples of addition and subtraction, let's instead look at multiplication, which will involve a lot of this combining like terms stuff anyway. All right, polynomials multiply via distribution. We always take one piece and distribute it across all the other pieces. And I think you all probably remember this. If I take this 2x squared and multiply it by this polynomial here, which is 10x cubed minus 5x plus 7, what I do is I take my 2x squared and multiply it, or distribute it across all 3 pieces. So multiplication distributes. If it would focus, I don't know what it's up to there. Okay, so I'll just say multiplication distributes. Okay? All right, so let's actually work this one all the way out. Let's go ahead and distribute that 2x squared across these 3 terms. All right? So it'll be 2x squared times 10x cubed. Then it will be 2, and there are 2 ways you could do this. You can go ahead, I'm writing way more steps than you probably ever want to. But I'm going to say this is plus 2x squared because you bring the sign of this guy along when you do this. Okay, so it'll be plus 2x squared times minus 5x, then plus 2x squared times 7. And then you can multiply each of these pieces individually like we did in the previous lecture to come up with your final answer. Okay, and like we did then, we will multiply the constants together, we'll multiply the x's together, and when you multiply these x's, remember you sum up their exponents. Okay, so as you can see, this is starting to build, these topics are starting to build on each other. This 2 times 10 will give us a 20. This x squared plus x cubed, remember, will give us x to the 5th. It's really common mistake to actually multiply those exponents, but remember, you sum up exponents when you do the multiplication. And if you're ever unsure about that, think about what these are saying. That x squared gives me 2x's, that's x times x. And this x cubed gives me 3x's, x times x times x. And how many x's do I have in total there? 5. So it's x to the 5th. Okay. This 2 times negative 5 is going to give me a negative 10. And this x squared times x, add those exponents. Remember, this has an imaginary, not imaginary, but an invisible 1 there. So this will be x cubed. And this 2 times 7 will give us 14. And then x squared. All right, we don't have another x to multiply that with. And check that out, that's already in standard form. Our final answer is 2x to the 5th minus 10x cubed plus 14x squared. So remember, multiplication distributes. You take this piece and distribute it across each other piece. Well, then the question becomes, well, what do you do if your first polynomial, first function, has more than one term? Well, we'll look at that. All right, take this example. This is fairly simple. I think this is something you've seen before. And I know some of you look at this and you think FOIL. All right, oh yeah, this is FOIL. This is when we multiply what we call a binomial times a binomial. Right? Binomial for 2-termed polynomial. FOIL stands for first, outside, inside, last. Well, all we're doing with that, if you think about it in terms of distributing everything, what I'm going to do is first take the x and distribute it. Sorry about that. Sorry about any camera jostles. I'm going to take this x and distribute it across the first term and the next term. Okay, just like we did in the example before, where we took that term and distributed it across everything. When we do that here, we take that x and distribute it across those 2 terms. And then we take our next piece too, and we distribute it across all the other pieces as well. Of course, my pen decides now that it doesn't want to work. Okay, so we start by taking the first term and distributing it across the terms of the second polynomial, and we take the second term and distribute it across the 2 terms of the second polynomial. All we're doing is making sure that we distribute every term here across every term here. Now, for this particular thing, math teachers have come up with this acronym FOIL. And what FOIL basically says is first, outside, inside, last. Well, first, that's this one here. That's taking the first guy, multiplying by the first guy. Outside is taking the first guy and multiplying it by the second guy in the next one. So it's our outside term. Inside, that's taking this second term and multiplying it by the first term here. And then last is 2 distributing to this negative 1. Okay? So all FOIL is an acronym to help you kind of remember this idea with a sort of 2x2 setup. But all you're really doing is just making sure you take every term of your first polynomial and distributing it across each term of your second polynomial and making sure every possibility gets taken care of. What I mean by that, well, x gets multiplied by every possible thing here, and 2 every possible thing here. So it's going to be x times x. Okay. Then plus x times a negative 1. Then, so that's distributing the x across. Now I'm going to distribute the 2 across. So it's going to be 2 times x, and then 2 times negative 1. Now, of course, some of you are probably wringing your hands here and upset that I'm not just doing the multiplication as I go through it. I will start doing that, and you can. I just kind of want to show explicitly exactly what's going on here. Okay, and we'll simplify this down. This x times x will give me an x squared. This will give me a negative x. X times negative 1. This is just a 2x. And this is a minus 2. Okay? And now we combine like terms, and we'll be finished. Okay? Combining like terms is negative x plus 2x. Negative x plus 2x. So that's a negative 1 plus 2. That's just going to give me x. Or you can write 1x if you want. Be careful with that, though. On MyLabs Plus, it tends to not like that. I've had it mark some students wrong for putting a 1 down, which is a little silly in my opinion, but it's sort of the nature of the finicky online beast. And there we go. Okay. We're done. This is a degree 2 polynomial. It's already in standard form. And like I said before, part of the multiplication process a lot of times ends up being the combining like terms process. Alright, and part of the reason why I'm making this big deal about breaking down what FOIL is actually doing and talking about this distribution method is because FOIL is not going to help you on a problem like this. Right, on a problem like this, we don't have just the 4 terms to do a first, outside, inside, last. But if we just remember that all we need to do is distribute everything across everything, we'll get the right answer. And then we just need to combine like terms when we're finished. All right, so I'm going to start. So by, if you can see this, it's in focus, this x squared, I'm going to distribute the x squared across these 3 terms. Okay? And here now I'm going to go ahead and start doing the multiplication just as we go. Right? This x squared times 1, of course, is going to be just x squared. X squared times a negative 3x squared. Well, that will be negative 3. Then x squared times x squared is going to be x to the 4th. Okay. Then x squared times negative 5x to the 4th. Well, again, the constant part's going to stay the same, right? Because we just have a 1 here. So it's going to be negative 5, and then x squared times x to the 4th, that's going to be x to the 6th. Remember, 4 plus 2, we're going to add the exponent. So there we go. We have now distributed the x squared across, right? And that's that for those 3 terms. Now we are going to distribute this 2x across. Now this is going to be a little different because here we have an x, okay, and we have a coefficient out front. That's what we call that constant sitting out front. And it's going to interact with these other coefficients that we have. Okay? But for our first distribution, this 2x times 1, that's going to be just as simple 2x, because 2x times 1, or anything times 1, is just itself. All right. Then I'm going to distribute this 2x times the negative 3x squared. So the 2 times the negative 3 is going to give me a negative 6. And the x times the x squared is going to give me an x cubed. Okay. Hopefully it will focus sometime today. All right. Now, so that's that distribution. Now this final one, this 2x times this negative x to the negative 5x to the fourth, that 2 times the negative 5 will give me a negative 10. And then x times x to the fourth, we add those exponents, and so we're going to get x to the fifth. All right. So there is that. We have now distributed everything, and now we need to combine like terms if we can, and then perhaps finally put it in standard form if it's possible to, or if it's not already there, I should say. Always possible to put it in standard form. Let's see if we can combine any terms. It doesn't look like we can, because x squared seems to be the only x squared term, x to the fourth seems to be the only x to the fourth term, x to the sixth, x seems to be the only x cubed seems to be the only x cubed, and x to the fifth seems to be the only x to the fifth term. So it looks like there are no terms we can combine here. We just need to put everything in order. So the highest power seems to be negative x to the fifth. Remember, you take the power along with it. Or, sorry, not the power. You take the sign along with it. Okay. Next up seems to be this negative 10x to the fifth. The next one seems to be this minus 3x to the fourth. Then it's minus 6x cubed plus x squared. Do we have an x? Yeah, plus 2x. And I think that's it. We don't have a constant, so here we are in standard form, and our degree is 6. All right, our next example, we're just going to keep ramping this up. Again, here's a place where FOIL wouldn't really help you. Here we have a trinomial, so a 3-term polynomial times another trinomial, 3-term polynomial. And again, FOIL is not going to help, but as long as we just distribute everything across everything, we're going to be fine. So I'm going to start by distributing this 3x to the fifth. I'm going to do the multiplication as I write out the distribution lines. So I'm going to take 3x to the fifth and multiply it by 5, the first guy. So there's no x's here. So this 3x to the fifth times 5 is just going to be 15x to the fifth. Okay. Then I'm going to distribute 3x to the fifth across to 7x squared. So the 3 times 7 is going to give me a 21, and x to the fifth times x squared is going to give me x to the 7th. So plus 21x to the 7th. All right, then we're going to distribute across the final piece, and that's going to give me the 3 times a negative 9 is going to give me a negative 27. Then the x to the fifth times the x cubed is going to give me x to the 8th. All right. So there's the distributing the first term. So the first term's taken care of. Now we're going to distribute that second term. So we're going to take this negative x cubed. Now, here you start to see the wonders of 1. This negative 1, it's not going to affect any of the numbers here. It's just going to change the sign, and all we need to worry about are the powers of x. I'm going to distribute this with its sign across. So that'll be negative x cubed times 5. So that'll be negative 5x cubed. Okay. Then I'm going to distribute this x cubed over to the 7x squared. Okay, so that's just going to make it a negative 7. Then the x cubed times the x squared is going to be x to the fifth. And then I'm going to distribute this x cubed, or negative x cubed, to this negative 9x cubed. So negative 1 times negative 9 will give me a plus 9. And then x cubed times x cubed, that will be x to the 6th. Remember, you add exponents when you multiply in this manner. Okay? You might see I'm getting close to running out of space here, so I could just shift this over, or I could continue this on the next line. Go ahead and shift it over for now. And now, so that's this piece complete. Distributed that. Now, I'm going to distribute this final piece, this 2x. So this 2x, we're kind of running out of space to talk about it, but I'm going to distribute it with green here. So this 2x times 5, that's going to give me a plus 10x. And the 2 times 5 is 10. The x times, well, a constant over here is just x. Okay. Then I'm going to distribute the 2x across 7x squared. So the 2 times the 7 is going to give me a 14. Then the x times x squared is going to give me an x cubed. And now I'm going to distribute finally this 2x across the negative 9x cubed. And so the 2 times the 9, or negative 9, be careful with that, okay, is going to give me negative 18, and the x times x cubed will give me an x to the 4th. So there we are with the distribution. Okay. Now all we need to do is combine like terms. So this one's kind of hairy, right? We can see that. But again, all I've done is made sure I distributed the first term across all the 3 terms here, the second term across all the 3 terms here, and the third term across all the 3 terms here. And now I'm going to combine any like terms I might see. And, well, let's see about that. First, I have this x to the 5th. And are there any other x to the 5th? So, well, let's see. X to the 5th here and here. Okay, any more? Not that I can see. So, what we have is 15x to the 5th minus 7x to the 5th. So that's going to be an 8x to the 5th. Okay. So we've taken care of those now. All right, next up is x to the 7th, 21x to the 7th. Are there any other x to the 7th? Not that I can see, so that's the only x to the 7th term. Okay, so that's done. Let me use a different symbol there so it doesn't get confusing. How about x to the 8th? I think that's the only x to the 8th term as well, so I'll leave that as it is. I'll use a different color now. Then how about x cubed? All right, we have 2 x cubed terms. We have one here and here. So I have a minus 5x cubed and a 14x cubed. All right, so when we do that calculation, we're going to get 9. The 14 minus 5 is going to give us 9x cubed. All right, and let's get those out of the way. Now, next up is x to the 6th. It's the only one of those I see. So, plus 9x to the 6th. And then, now that I've been marking things off, it's pretty simple to see. I have a 10x and a negative 18x to the 4th. So that's just what's left. Those aren't going to combine. And we've got it. So the only thing we might want to do now to get our final answer, if asked for, and a lot of times MyLabs Plus does just because it's, you know, cantankerous, is put it in standard form. So put it in order. So the highest power of x I see is 8. Now remember, when you do this, make sure you just keep the sign with it. Okay. The next highest power is 7, so plus 21x to the 7th. The next highest power seems to be 6. Seems we're going in order here nicely. All right, we got 6. Is there 5? Yep, plus 8x to the 5th. There's a 4 minus 18x to the 4th. Okay. Plus 9x cubed. Okay. And let's see, is there an x squared? No, plus 10x. And there we go. So here's a degree 8 polynomial. And it doesn't have an x squared term or a constant term. Okay? So a couple things to keep in mind here. For instance, a degree 8 polynomial could have up to 9 terms in it, right? One for each power of x and a constant. Right? And some other things to keep in mind here. What we did when we multiplied this thing together, this was a degree 5 polynomial, if you can see it. This was a degree 5 polynomial, this was a degree 3 polynomial. When it came together, it came out to be a degree 8. Well, 5 plus 3, that's 8. Right? Typically, when you take a degree 5 polynomial and multiply it, or what did I say there? Typically, when you take a degree 5 polynomial and multiply it by a degree 8 polynomial, you basically add the degrees together, and that's what you end up with. So, say in this previous example we looked at here, I had a degree 2 polynomial and a degree 4 polynomial, 4, 5, 6. We ended up with a degree 6 polynomial. Right? You typically add the degrees together, and that's usually the result you get. There's some weird situations out there where that doesn't happen, but in general, expect to see that if you're taking a degree 5 and a degree 3 and multiplying them together, that you'll end up with a degree 8 in the end, which means the more pieces you have and the higher the powers you have when you do multiplications, the more and more and more possible terms that are possible. Alright, I think this is about the most complicated thing you'd see in this particular section. The homework for this one is just a bunch of practice on this stuff. Also, there are people who learn this stuff using the box method. For this particular class, I have no problems with you using that method if that just helps. I think once you get the hang of this, though, just distributing, it actually works out a lot faster and a lot less space than, say, the box method does. But as long as you're getting to that correct answer, especially in this online class, I think it'll be all right. So, all right, again, email me with any questions you might have, and I expect to see the lecture for lesson 3 here soon. Cheers.